0, 3, 2, 1, action.
Welcome back to my tutorials. My name is Engineer Ivan Forts, and today I will be talking about IP addresses. IP addresses are very important because it is what the router actually receives and needs to route the information and follow the right path to the destination. So the first thing is to understand that an IP address is composed by 4 octets. An octet is a group of 8 bits. So if we multiply each octet, we are going to see that we end up with 32 bits. IP addresses are also classified according to their class. We have a class A, class B, class C, class D, and class E. For this purpose of the video, we are going to focus only on these 3 classes here, because these classes D and E are mostly for experimental and military applications. IP addresses are located at the network layer of the SI model because this is where our routing takes effect. What is important for an engineer when you look at an IP address is to segment the IP address into 2 entities: the network identification and the host identification. Each IP address has its own subnet mask. For the class A of IP, you have this subnet mask. Class B, you have this subnet mask, and class C have this subnet mask. So basically, let's give an example and see how we actually can use the theoretical foundation illustrated on the board into a network. If you are giving, for example, this following IP address, 192.168.1.7, and you are asked to tell what is the net ID and what is the host ID, there are 2 different methods. The first method is to look at the first octet from the left and compare it to the range of IPs you have here. And you can clearly see that in this particular case, this IP address is located on the C range because it's within the range of 192 to 223. So we can say that this IP belongs to the class C. So this is the first way of identifying a class to an IP address. Another way is to use the subnet mask. So for example, 192.168.1.7, okay, is a class C. So the mask, the subnet mask will be this one. And if you bring down the numbers, the octets that has the subnet mask, you end up with this one. And this last one will be the host. So here we have the net ID, and here we have the host ID. This is a very nice way of doing it also. So basically the subnet mask, it is a tool that allows us to identify which segment of the IP address belongs to the network identification and which segment that belongs to the host. This can also be applied for any other class. For example, if I give an IP 10.10.7.3, we can apply the first method by looking at the first octet, comparing this first octet to the ranges above, and we conclude that this particular IP belongs to a class A of IP addresses. And we can also see clearly that by using the subnet mask from the class A, we end up with 255.0.0.0, who tells us that this particular IP has as net ID the network 10.0.0.0, and as host ID we will have the other 3 octets. And this will be the host ID. Another very important thing to know when you choose a class of IP address to work with is to say how to determine how many networks can I have by using this class of IP and how many hosts we can have. So you can see here, for example, on a class A, if you decide to work with a class A of IP, you can produce 126 networks and you can have this many numbers of users. If you're using a class B, you have this amount of networks and you're going to have this amount of hosts per network. And you can have also on a class C these numbers. Now, it's very interesting. Let me show you how you come up with these numbers. Alright? You come up with this number based on this formula. If you want to calculate the number of possible networks by using this formula, the N that you can see refers to the number of bits part of the host and part of the network. And the W is going to be the number of hosts. So let's look at it. On a class C, for example, how do we got to these numbers? Let's see. A class C, what you do, if you look at the class C here, you see that we are using, on the network part, we are using 8 plus 8 plus 8, which is 24 bits. Okay, but on the host side, we are using only 8 bits. If you deduct the 3 not usable bits, which is basically the 127, the 0, and the 255, you end up subtracting 3 from the formula. So let's see. So N is equal, for this case, to 24. We subtract 3, we end up 24 minus 3, we get up to 21, and this will give us the total of 29,752 hosts. Networks. And in terms of hosts, we are looking at the host size, 8 bits, so we apply this formula, which is going to be 2 to the 8 minus 2. We come up to the number 254 hosts. That's how you, so basically, if it's a class A, you subtract 1, class B, you subtract 2 to get these numbers, and for class C, you subtract 3. Now, it's very also important to understand that the number 127 is not usable unless you are trying to troubleshoot your local network card by using what is called a loop-back address. Basically, if you want to know if your network card is responding to the packets that are transferred, what you can do is to create an IP address that starts by 127, and then you ping your own network card, and you will see if the ping is positive, if the ping is replying positively, and then it means that the network card is totally functional. So it's very important to understand that IP address is the foundation. In this case, we're talking about IP version 4, and in the next video, very soon I'll be presenting IP version 6. Thank you very much. If you want more details, you would like to have more explanation about IP addresses in any way, please feel free to contact us directly. Thank you very much. My name is Ivan Forts.